Let's create a Python script as a network engineer learning to code. First, set the variable a to equal 192, b will equal 168, and c will equal 0. For d, we can use the inRange function, and for every value in the range of 0 to 255, we are going to print the string a.b.c.d, where d will change every time we iterate through the loop. When the script runs, we will see every IP address from this /24 range print to the terminal. Let's expand our IP counter script. This time, instead of a /24, we want a /16. First, indent your current loop. Then, in place of c equals 0, use for c in range of 256. This will nest the loop for d inside a loop for c, giving you all /16 addresses printed to terminal. Having iterated through every /16, we can now adapt the script to print the .5 address in every /24. To do this, remove the d loop, replacing it with d equals 5. And because the loop no longer exists, we need to pull back the indentation for the print line. When you run this script, you'll see the fourth octet is static, while the third increments by 1 every time. Let's turn this into configuration. To save some space on screen, we can add some new variables for later use. Int f will be a string equaling interface VLAN. VLAN will equal integer 2. IP is a string for IP address, and MS will be the string representing the subnet mask 255.255.255.0. Next, above our current print line, we will add a new print statement to print variables int f and VLAN. On the existing print line, we'll add the IP variable to the front and the MS variable to the end. Finally, we need the VLAN ID to change every time we loop through this for loop. To do this, we can use the += operation to add 2 to the current VLAN value. When you run this script, it will output valid configuration, where the VLAN will increment by 2 every time and the third octet by 1. Our script is working, but it's a bit of a square peg in a round hole. The IP and VLAN scheme don't work well together. By changing only 3 lines of this code, we can make the output far better. First, let's set the initial value of the VLAN to equal 10. Then we can add 10 to the VLAN on every loop. With the for c loop, instead of every value between 0 and 255, let's start at the value of 10 and go up to 80. Finally, we can make the loop count in groups of 10, so 10, 20, 30, etc. When this runs, the output will be a much neater design where the VLAN ID and the third octet match. While printing output to terminal can be useful to us, it isn't really usable programmatically. So instead, we can store these outputs for later use. To start, let's create a new variable called int_config, which is an empty list. Now we can replace both print statements with the command int_config.append. This will add each string as an item within the list. Finally, just to prove it worked, let's print the list to terminal. When we run this script, the output won't be pretty to us, but programmatically, this is gold. For the next part of our script, we need a device to play with. We're better than developer.cisco.com. Under Sandbox, select Build and Launch Sandboxes. Log in with either GitHub, Google, Cisco, or WebEx accounts, then search for 8K to find the reservable iOS XE on Cat8K. Then select Launch. From here, select the duration of your lab, which is defaulted at 1 day. Selecting the launch environment will begin the spin-up process. This usually takes about 10 minutes with the 8K. While this runs, check out the Instructions tab. This will give you details about the lab that includes the VPN connection details you'll need, but most importantly for us, the access details for the switch, including IP address, username, and password that we will use in the next part of our script. To connect to the 8K on DevNet, we need a tool that isn't native to Python. On the terminal, issue the command pip install scrapely. Then, from this new scrapely library, we will navigate through its driver and core folders and import the iOS XE driver toolset. Now that's set up, we need to set the device details. Create a new variable called 8K. This will be a Python dictionary with key and value pairs. The host can be either IP address or domain name, and the auth username and password should be the values provided in the sandbox. Set the auth strict key to the Boolean value of false. Finally, let's prepare to connect. The con variable will use the iOS XE driver tool and the dev8k details we have configured. With everything set up, let's test our connection to the Catalyst 8K on DevNet. But first, let's mute that print line at the end of the script with a hash. The con variable is now our most powerful tool, and we can use it to establish an SSH session with the .open operation. Next, we can create a variable, response, that will store the output of the con.send command operation that will send the string show IP int brief to the switch. To see if this works, we can print the variable response, which will return the success true or false message. To see the output, however, you can print response.result. The script may take a little longer to run this time, as it now needs to connect to the device and issue commands. But the output? Totally worth it. We are now ready to push config. At the end of your script, create a new variable called sendconf. Using the con.sendconfigs operation, we can push the int_config list with all the VLAN interface configuration to the device. If we leave the last show IP int brief response in place, we can now achieve a before and after view of the device's interface configuration by repeating the original response line but calling it something else like response2, then printing its results to the terminal. Running the script will push the new config and display a before and after show IP int brief, showing all the new VLANs that you have just configured programmatically. And there you have it, you have pushed config. To keep a log of the changes made, let's import the datetime library and create a new variable called start at the beginning of the script. This variable will be the string of the current time. Repeat this at the very bottom of the script, calling the variable end. Using the withOpen operation, let's now create a file called changelog with the write w permissions as a variable called f. Then, using the .write function of the f variable, we can now write content to the file. This can be the start time, the commands that we send, the show output, and the time that all of this was finished. When you open up the file, you'll have it all to hand. Passwords in clear text? We can't have that. So from the getPass library, import the getPass module. Now we can create a new variable called password, where we'll use the getPass function with the prompt operation. The prompt will ask the user for the password. Then change the clear text password in the Python dictionary to be the new variable password. For a little fun, let's access this value from the Python dictionary. We can do this by printing the dev8k key auth password. When you run the script, the prompt will ask the user for input, and keystrokes are recognized but not displayed. And because the value is stored, we can now access it programmatically.